Hi, uh, our topic this week is population and urbanization, as you can see in this class schedule. And let's get right to it. And that's a more fancy title of this week's lectures: Population and Urbanization, Trends of the World and Korea. In case you're wondering, the topic of population is often discussed together with urbanization because they often go hand in hand, meaning population growth is often associated with higher urbanization of any given society. Okay, this is the lecture outline. Quite a few things to cover, but many of these sections are rather short. So don't worry, I'm not going to take more of your time than necessary. Okay, so after a brief introduction, I talk about the sort of the nature of world population, or how it grew at a rapid rate. And that is followed by, what experts say about population growth or its impact. And then I talk about population in Korea. And then after, talking about population, I naturally turn to the issue of urbanization. And, one of the first things to talk about urbanization is the types of urban settlements, like city and suburb and so on, right? Well, as there are views on population growth, there are also views on urbanization, meaning what urbanization means for contemporary people, okay? Whether it's USA, Canada, or Korea, lifestyle of urban area is definitely different from lifestyle of rural areas. And the last three are focused on Korea, where, I talk about the stages of urbanization in Korea, characteristics and problems of urbanization in Korea. And the last section is devoted to comparing urbanization process of Korea with that of the West, for example. Okay, well, it was a rather lengthy introductory remarks on this topic of population and urbanization. But I want to start off with really an excellent documentary, or not a documentary, but a piece from 60 Minutes. So it does say a lot of things I want to say, and that is how explosive population growth will have dire consequences on the planet, planet's resources, biodiversity, and the well-being of other species on the planet. Okay, so let's watch this for 30 minutes or so, and then I'll start my lecture. Can you see the slides?
Yes.
Okay, thank you. Okay, I hope you enjoy the video. I hope it's not your first time hearing about the 6 mass extinction. Just to give you a follow-up on the mass extinction, the Earth is said to have experienced 5 mass extinctions in its prehistory history. And the last one happened to be the extinction that brought about the end of dinosaurs, right? So anyway, if you're interested in this, search mass extinction or 6 mass extinction, and you'll get many interesting hits. Anyway, let's move on. So it took nearly all of human history to add the first billion people to our planet, a number that was reached only 2 centuries ago in roughly 1804, around 1800. It took another 123 years until 1927 to add the second billion. And it took 33 years to add the third billion, 14 years to add the fourth billion, 13 years to add the fifth billion, 12 years to add the 6 billion, and another 23 years to add 7th and 8th billion. As you know, last year, world population reached 8th billion. And so I already mentioned that. The question is, given the past and recent rates of exploding population growth, what do you think is the most widely accepted official prediction for the global population in 2050? So that's about 27 years from now. Well, pick your answer. A, 9 to 10 billion. B, 14 to 15 billion. C, 19 to 20 billion. D, 24 to 25 billion. And lastly, E, 29 to 30 billion. Again, think about how long it took for humanity to reach its first billion, second billion, third billion, and so on, right? Anyway, I'll give you the answer in the next slide. And it goes like this. Well, it is difficult to predict with any precision the rate at which the world population will rise. But UN researchers have produced several scenarios. But their most likely estimate assumes medium levels of fertility. For example, on average, women throughout the world are having, about 2 children. Actually, right now, as of 2022, global fertility rate is like 2.4. So if we stick with that, and that fertility rate will be maintained in the next 23 years, then the world population will reach about 9.8 billion by 2050. Okay. So if we go with this scenario, the correct answer is A, 9 to 10 billion. Population change is an important source of other changes in society, especially economy, urbanization, and environment. We don't really make this connection between population and environment, but just think about how when you have so many people, then you need to produce that much more food to feed these people, right? That means destroying forests to create agricultural land, and also to destroy forests to create grazing land for farm animals. So the population increase has a direct impact on the environment. It is thus important to examine the complex ways in which population growth, urbanization, and our planet's fragile environment go hand in hand particularly against the backdrop of rapid industrialization. The study of population is so important that it occupies a special subfield within sociology called demography. Demography is the study of changes in the size and composition of population, including birth rates, mortality rates, and migration. Well, that's sort of an introduction to this whole population topic. And the next section, so the question is, how have the world population and the Korean population changed? What have been the views on population growth? How has urbanization progressed in Korea and the world? What are sociological perspectives on urbanization? And what are the characteristics and problems of urbanization in Korea? So these questions are sort of repetitions of the sort of lecture outline, right? So they should pose no surprise to you. Anyway, the next section is world population. One of the most important changes regarding population has been the rapid growth of the world population. So just for fun, and I probably asked this question at my first lecture, maybe this would be a reminder then. What was the world's population 10,000 years ago? That is 8,000 before the Common Era. Well, as you may remember, at the dawn of agriculture, so 8,000 BCE coincides with a beginning of agriculture in the world, and the population back then was about 5 million. Okay, so keep that number sort of in mind. Whereas it had taken all of human history until around 1800 for world population to reach 1 billion. The second billion was added in only 123 years in 1927. And I've already done this earlier, right? So I'm gonna just show you this. Perhaps the last two, right? So the 8th billion was reached last year. The 9th billion will be added, will happen in 2037, and the world population will reach the 10 billion mark in 2057. So world population today is 8.4 billion, and forecasts go like this. So it'll reach 10 billion by 2057. And by 2100, the end of this century, the world population will exceed 11 billion. Okay. So this is the sort of the visual image of how rapidly world population grew, especially in the last 2 centuries. And as far as the rapid growth of world population is concerned, a tremendous change occurred with the Industrial Revolution. High population growth during this period was facilitated by, among others, increase in food production, better sanitation and hygiene, and improved medicine. Okay, so a lot of things happened during the Industrial Revolution. So as I say one more time, look this up. And I think the Wikipedia is a nice entry explaining what happened during this period. So between 1804 and 2011, that's about 207 years, the world population increased 7-fold, jumping from 1 billion to 7 billion. World population has doubled in 40 years from 1959 to 1999. During the 20th century alone, the population of the world has grown from 1.65 billion to 6 billion. And this is the killer. I think this is the most alarming figures. Okay, between 800 BCE and 2023, we're talking about slightly over 2,000 years, right? The world population jumped more than 1,600 times. So I don't know about you, but that seems to me is definitely too much. Okay. Anyway, to move on to some visual images or figures. Well, thankfully, the growth rate of world population has been decreasing. So again, the graph shows yearly growth rate of world population. So the highest growth rate was in like the 1967, 1970, when the world population grew at a rate of more than 2%, right? But as of 2019, it's down to less than 1.2%. But given such a huge population size of the world, that is also quite significant, right? And this shows you how women are having fewer children, globally speaking. The figures you see are the global fertility rates. So back in the 1950s, 60s, and 70s, early 70s, the global fertility rate was above 4.5. Okay, but as of 2017, it's down to below 2.5. And I'm sort of jumping ahead, but the latest figure for global fertility rate, let's say that's global fertility rate for last year, was like 2.4. So anyway, it's getting better. And since we're talking about world population, I just wanted to show you how for a long time China used to have the world's largest population, but starting this year, India became the #1 country as far as having the largest population in the world is concerned. It pushed China to second most populous country. Well, it's also good to know about what's going to happen in the future. So by 2100, India will continue to be the #1 country as far as having the largest population is concerned, and it'll actually even grow, meaning its population will actually be larger than its total now, whereas Chinese population will significantly decline. It'll decline by about 1/3 if the current population trends are maintained. Another big surprise from the table on the right is that Nigeria, which is currently the sixth ranked country as far as the population is concerned, will jump to third ranked, or it'll become the third most populous country in the world, with 750 million. So okay, so that's that. All right, moving on to the next section, views on population growth. And I don't know if you're familiar with this Malthusian theory from 1798. It's just mind-boggling to actually have a scholar or thinker for making this kind of predictions, so far back in time. Anyway, English economist Thomas Malthus said that population increases geometrically, meaning it doubles, like 2, 4, 8, 16, 32. while food production increases only arithmetically, meaning 1, 2, 3, 4, 5, 6. So you can see how the two types of growth, big difference, right? So again, the geometric increase refers to something doubling. So it's sort of increasing at a very rapid rate. And arithmetic growth is more gradual. Whatever it is, it increases from like 1 to 2, 2 to 3, 3 to 4, right? So because of this, according to Malthus, so if left unchecked, the population would exceed the available food supply, leading to mass starvation. So for a long time, Malthusian theory sort of prompted many policymakers and many concerned experts to be worried that so many people all over the world will starve to death, right? But did it happen? And of course, the answer is no, because we were able to revolutionize how we do agriculture, meaning we were able to genetically modify certain food products and also develop better technology to grow our food supply more efficiently, leading to greater production. Okay, so yes, we had some issues with starvation in certain areas of the world, and that was not because the world was suffering from food shortage. It happened because of lack of efficient distribution or lack of willingness to share food surplus. Okay, so that is Malthusian theory. Again, he was proven wrong by our technological advancement. But a second view or theory on population growth is called zero population growth. It's actually a neo-Malthusian view that calls for a goal of zero population growth. So proponents of this theory argue that for the world to be sustainable, population cannot grow anymore. Okay? So that's why it is calling for a goal of zero population growth. And why do they say this? Because it is not food shortage, but the environment that will play a crucial role in the continued health of the planet's population. Do you get this? Again, neo-Malthusian view of zero population growth shares the view of Malthus that unchecked population growth is not a good thing. Okay, whereas Malthus reasoned that it was because of the lack of or shortage of food supply. But the neo-Malthusian view says, no, it's not the shortage of food supply because we have enough food. It's the environment, okay? Because large human population and their meat-based diet is having a devastating impact on the environment, okay? Using up and polluting resources such as water and air. So I hope you see this very different reason given for calling on policymakers all over the world to sort of curtail population growth. Okay. The preponderance of meat-based diet of humans is indicated by the sheer number of farm animals. I don't know if this is something that you have heard about or thought about, but humans are easily outnumbered by farm animals. The combined total of chickens, 19 billion, cows, 1.5 billion, sheep, 1 billion, and pigs, 1 billion. So this is from 2019, and I think the total could be higher than this, but the point is, at any given time, farm animals outnumber humans. Okay? And out of all the world's crop, that is grain, fruits, vegetables, etc., only about half are actually eaten directly by people. The rest is for animal feed and for biofuels and other industrial uses. So can you imagine all the foods we produce is not for our own consumption, but for other needs as well, you know, to feed other animals who will eventually be slaughtered for our own consumption, right? And 33% of agricultural land worldwide is used solely for livestock feed production. Okay, so that's why those who call for zero population growth argue that it's not just the growing human population, but also their meat-based diet, and that is, you know, something that a large majority of human population engage in, right? I think for the overall human population, vegans or vegetarians account for, again, as an overall figure, less than 10% for sure, right? And because meat has become so cheap, so many people are eating more meat than ever before, and that is killing the planet. Okay. Anyway, as of 2018, more than 70 billion land animals were slaughtered for food worldwide. An average person living in a developed country who is not a vegetarian or vegan will consume approximately 7,000 animals during his or her lifetime. Global meat production is responsible for more greenhouse gas emissions than all of the trains, cars, and airplanes in the world combined. So, in a nutshell, increased meat production and consumption are all intimately related to rapid population growth, which is, in turn, linked to climate change and global warming. So that will just make life on this planet more difficult to endure, right? And I think the global warming that will cause rise in sea level will cause much more havoc on the lifestyle of humans in the near future, right? Well, let me just take a look in passing. So what is noticeable here is that, although India has the world's largest population, the meat consumption is relatively far lower than many other countries and regions because of its religious beliefs. Hinduism and also Buddhism, emphasize vegetarianism or veganism because they recognize all living beings as having the right to live. So that's why, you know, they are not supposed to kill other living beings because they believe in reincarnation. So even a cow would be is reborn from from a different being. So the cow, it could be in former life, might have been a human being, right? So anyway, it's not a proper representation of what those religions are, but anyway. Greenhouse gas emissions per calorie. So we're now getting into foods and how much it causes damages to the planet. And I don't know if you have heard of water footprint, how much water it takes to produce, for example, 1 cup of tea, 1 cup of coffee, 1 kilogram of wheat. And as you can see, producing 1 kilogram of beef causes or requires the most amount of water, at least what you see on this particular slide, right? But something that I find even more surprising is the next slide, because you look at this, and I don't know if you're a big fan of chocolate. So producing 1 kilogram of chocolate requires more water than producing 1 kilogram of beef. Again, I don't know if you remember, but to produce 1 kilogram of beef, it takes over 15,000 liters of water. But for producing 1 kilogram of chocolate, it requires a whopping 24,000 liters of water. Oh, well, there's that 1 kilogram of beef right next to it. Anyway, so by eating less meat, we can help fight climate change, reduce water use, reduce pollution, and prevent further habitat destruction and species extinction. The world population of 8 billion people represents just 0.01% of all living things, but since the dawn of civilization, humanity has caused the loss of 83% of all wild mammals and half of plants. So this section was rather long. Again, this one focused on the second view on population growth, and that is zero population growth, or the view of neo-Malthusian theorists. And the next one, and the last one on the views of population growth, is what is called the demographic transition theory. The demographic transition theory suggests that future population growth will develop along a predictable 5-stage model like this. So according to the 5 stages of the demographic transition, you can see there's stage 1, stage 2, stage 3, stage 4, stage 5, right? So in stage 1, population growth is minimal, or actually it does not grow because there is high birth rate, but is negated by high death rate as well, okay? Now in stage 2, there is rapid increase of the population because while birth rate remains high, death rate falls rapidly because of the improved sanitation and hygiene, increase in food production, and also improved medicine. Okay, so this happens as country is industrializing. Okay. In stage 3, this is also at a sort of a industrialized stage. Birth rate sort of falls because with improved standard of living, and increased educational attainment, women have less number of children, and death rate also falls, but more gradually, right? So the rate of population growth has slowed down compared to the stage 2, okay? And in stage 4, you have low birth rate and also low death rate. So the population growth is stabilized, okay? And in stage 5, although on this particular figure says yet to be seen, it is definitely happening in Korea. It's happening in Japan, at least, right? Where birth rate is not low, but lower than that is necessary to maintain a stable population. And death rate is low, but it's increasing because of the aging population, okay? So if you're not so sure about this, look it up. Again, demographic transition theory, okay? And you get more information about this particular theory, which is, again, a view on population growth. Okay. Let's finish this particular section before we take a break. And it's population in Korea facts. Current population is over 50 million as of 2022. South Korea's population ranks as the 28th largest in the world, and population density is 512 per persons per square kilometers, and that's the 24th most dense population in the world. And fertility rate in Korea, this is a typo there, it's 2022.78, and the world average as of 2022 is still about 2.4. And remember the population replacement rate, right, which I talked about before. And what's happening in Korea is actually population decline, okay? Population in Korea declined for the first time ever, not first time ever, but in 2020, down about 20,000 from the previous year. It is the first time in 58 years that the nation's population decreased since such statistic has been compiled beginning in 1962. And what's happened is what is called population dead cross, the phenomenon in which the number of newborns is smaller than the number of the deceased, leading to a fall in the overall population has become a reality, okay? I have some typo here, I think. The number of newborns in 2020 was 275,815, the lowest level ever, while the number of the deceased totaled 764, which is about 30,000 more than the number of birth, right? So the reason I said there is a typo is what's above, right? I say in the first sentence down about 20,000, but that should be down about 30,000 from the previous year, right? So anyway, here is a visual image of what I just talked about. So 2020, there's a 2021, and it happened again in 2022, okay? This one I already talked about before, and given the current trend, as of 2067, Korean population can fall to as low as 33 million, okay? And this is the overall picture of how population increased over the years since like 1949, right? Okay, so let's take a break now, and I'll see you back in a few minutes. Thank you.